Assalamu'alaikum and hello everyone. My name is Ahmad Muazzuddin bin Mustaffa. Today I am proud to present my final year project, which titled Performance Evaluation of Password Attack Strategies Against SHA-256 Hashes. In today's digital world, most web services rely on the SHA-256 algorithm to secure passwords. However, because SHA-256 hashes are calculated so quickly, it ironically allows hackers to guess millions of passwords in a single second. The main problem is low security awareness. Users don't realize how easily their simple password can be cracked, and current password verification tools are too manual or only give vague string meters instead of real hard data. Hmm. Now, to the objective. To solve this, my project objective are threefold. First, to study the method of modern password cracking techniques such as rule-based attack, dictionary attack, and brute force attacks. Secondly, is to develop an extension to simulate the cracking difficulty of user-provided password to test and lastly is to test the functionality and security of the system. This tool is designed for end user on Windows Chrome browser. A key focus of the scope is privacy. All operations are performed locally on the user's machine without sending sensitive credentials over to the network. Okay. So this is my system architecture diagram. This is this diagram and flow chart. So the main contribution of this project is bridging the gap between complex cybersecurity tools and everyday user. Instead of just telling users their password is weak, this tool brings a professional grade vulnerability assessment and penetration testing directly into the browser. By letting users watch their own passwords get cracked in real time, we provide the hard data they need to actually change their habits. Oh, so this is my prototype development, my prototype, and then this is my result and discussion functionality testing. There's five of them. Is password capture, automatically detects and hashes password from the website. The result is pass. Attack selection allows user to switch between brute force, rule-based, and dictionary attacks mode. Is pass. Real-time metrics display attack speed and time taken without lagging. Pass. Then report export. Generate a clean PDF HTML security audit report. Pass. And lastly is anti-tampering block right-click shortcut to protect the UI. Pass. Static testing. XSS prevention. Purpose is for replace all I've replaced all inner HTML with text content to block script injection. So the result is secure. Improved validation. I use regex to ensure only valid 64 character hashes are processed. Result secure and data privacy. Password are hashed before being saved to local storage. Secure and logic hardening. I've used object.freeze to prevent hackers from changing config mid-attack. Secure. And lastly is DOM monitoring. Mutation observer detects and reverts any unauthorized UI changes to be secure. Now, now I'm going to demonstrate my system. Yeah. So for an example, any login page or any register page, I can use my extension. So actually this is um I've I've unpacked my extension here, and this is my interface for my extension. So now we can demonstrate for the UniKL. And outputs. And then so for example, in Swice, then the password I put is 11111. So my extension will pop up here. When the user finishes a detached simulation, dashboard opens automatically. Here, the user can select a attack strategy, missionary attack, rule-based attack, and brute force attack. I will using our loaded word list. As you can see, the system tests the hashes instantly. So this one, um, instantly and alerts the user if their password was compromised. So if I run this, well, yeah, it's gonna fail because 111 isn't in the dictionary. And then if I run the brute force attack, yeah, this is the real-time attack. It's gonna take a long time, so we'll stop here. And then after that, I can download the report and save as PDF if I want to give the report to my supervisor or any highest up. If you want to see the uh my extension is work right here, focus attack, and then okay. So the password is found here. We covered plain text and total execution time is 2 seconds and 4 milliseconds. Average speed is 117,000 at 10 per second. And then this is the heart and the hash and attack strategy. And then, yeah, this is my footer. And if I save by PDF, I can just, yeah. Then I'm going to demonstrate the simulated attack, the penetration testing. This one. Hmm. Right here, I cannot right click on my extension. So, but there's a way to to temper this my extension where I can inspect the pop-up. Okay. So if I want to adjust or rewrite my start button, I'm going to delete, and if I click enter, yeah, the tampering detected the warning message, and it cannot use my extension no more. And then there will be errors message here. Text content modification detected. Secure temper detected. Right. So that's all for my penetration testing. During the testing phase, the system achieved outstanding result in functionality testing. All core features, including password capture, text selection, and anti-tampering, passed successfully. For performance testing, by upgrading our architecture to use a synchronous custom SHA-256 method inside a dedicated web worker, the simulation speed increased massively to over 15,000 per second, 15,000 attempts per second, completely avoiding any browser lag. And finally, users can exploit a clean professional PDF security audit report summarizing the exact time and speed it took to break their credential. So looking forward to this project. Hmm. This project has a great commercial value as an user-friendly security training tool for school and businesses. Companies can use it to teach their staff how to create a stronger password by showing them how quickly a hacker could break into their accounts. It can be sold as a subscription service for professional security audits or bundled as a safety feature for web browsers because it protects user privacy while testing security. It is a valuable product for growing cybersecurity market. So thank you for your time. That's all from me. Thank you. Assalamu'alaikum.